right, so the third and final part of synthetic division is using it to factor. So if I have no remainder when I go through the process, that means I have found a zero. And if I have a zero, then I have a factor. So let's say I was dividing by 2. And just random numbers that mean nothing. I ended up with 0 remainder. That means that this 2 is a 0, which means that x equals 2. So to create the factor, I have to make this equal to 0 by subtracting 2 from each side, which means that this x minus 2 is a factor of this polynomial. So essentially, that's how we're going to use it to factor. It works with anything quadratic and above. I know factoring is something that you and I have worked on extensively. So hopefully a lot of that is still there with you and in your memory, because we'll be using parts of that as we go forward. So I want to factor this, given that f of 5 is a 0. If I'm told it's a 0, I'm going to use the 5. My coefficients, I have 1x cubed, 0x squared, negative 19x minus 30. Ideally, I want this right here to be a 0. So bring the first number down, multiply, add, multiply, add, multiply, add, and I do get a 0. So I know one of my factors is going to be x minus 5. These three are the coefficients. I drop a degree. X squared plus 5x plus 6. Now I want to factor this to find my other two factors. So if you remember way back to factoring, I want two numbers that multiply to be 6 and add to be 5. Both are positive. So the two numbers that multiply to be 6 and add to be 5 are 3 and 2. So these are the three factors of my original polynomial. If I were to multiply all these three together, I would end up right back here with x cubed minus 19x minus 30. This also allows me to get my zeros, because if I set each of these equal to 0, I know they're going to be 5, negative 3, negative 2, the possible values of x. That'll make this 0. So to try it yourself at the bottom. Again, I'll give you a couple seconds if you want to pause it and try it. If not, we'll jump right into it. All right, so again, I'm told that one of the zeros is 4, so I should definitely have a remainder of 0 here. Coefficients are 2, negative 1, negative 25, and negative 12. First number comes down, and then I multiply. Add, multiply, add, multiply. I get my 0. I know x minus 4 is a factor. I now have 2x squared plus 7x plus 3. And now I want to factor this to get my final two factors. So if you remember, when I have a coefficient here, I have to multiply this times the last number. And we use the x. So So I want two numbers that multiply to be 6 and add to be 7. So that's 6 and 1. I'm going to take this and rewrite the middle term as 6 and 1. 6x plus x is 7x, so that's just a 6 and the 1. Then I'm going to look at the first two terms and take out the greatest common factor of 2x. And the second two terms, the greatest common factor is 1. Combine my outside to 2x plus 1. Keep one of my inside, x plus 3. And those get me my 3 factors of my original cubic polynomial. Whatever is the highest degree is going to let me know how many factors I'm going to have. So if it's quadratic, I'm going to have 2, cubic 3, to the 4th degree 4, and so on and so forth. The third example at the top of the right column says when x equals -1, in other words, when -1 is a 0, we're going to have -1 on the outside. My coefficients are 1x cubed, 1x squared, -4x, and -4. Bring that first number down, multiply, add, multiply, add, multiply, and I get a 0. So I know x plus 1 is already a factor. That's coming right from there. So now I'm dropping a degree, started with cubic. I'm going to x squared, 0x minus 4. If I remember, that x squared minus 4 has a special factor that I can do without much thought. So I'm just above the halfway mark of the page, where I have 3 blanks. This is, remember, the difference of squares. So I have 2 perfect squares. So I have x minus 2 and x plus 2, because the square root of 4 is 2, and the square root of x squared is x. So then it says, by the factor theorem, the zeros are, and that's just making each one of these equal to 0, or what values of x will make each one 0. So my zeros are going to be -1 for the first one, +2 for the second one, -2 for the third one, giving me my 3 zeros. Which leads us to the last example, but try it yourself. This one has a little bit extra in it. So my exponents are 1x to the 4th, 0x cubed, -5x squared, 0x, and 4 is a constant. Because they tell me it's going to equal 0, this had better equal 0. Bring the first number down, multiply, add, multiply, add, multiply, add, multiply. Perfect. So I know x minus 1 is a factor. Start off with x to the 4th, so I'm going to drop a degree. X cubed plus x squared minus 4x minus 4. I'm not at a quadratic yet or somewhere comfortable factoring. So now I have to kind of trial and error play my way through it. I know this last number is -4. So the things that are going to multiply to get to -4 are only going to be 1, 4, 2, 2, and the negative versions of those. So -2 and 2, and either -1 and 4 or 1 and -4. So any one of these could be my zeros. I'm gonna try 2 because I did a little advanced stuff or stuff in advance. So again, my coefficients, I don't need to write this out. I can just bring these straight down, but it's 1, 1, -4, and -4. My goal again is to get a 0 here. First number comes down and I multiply. Add, multiply, add, multiply, and I got a 0. That worked out tremendous. I know x minus 2 is a factor. Now I'm back to familiar ground. And you're not going to encounter much of these in this unit. So this is the only one, but it's in the book, so I wanted to show it to you. This becomes x squared plus 3x plus 2, which is a nice and easy factor of x plus 1, x plus 2, because there's only 2 possible numbers that multiply to be 2, and they just happen to add to 3. So going back up, I see that I also have x minus 2 as a factor, and a little further up, I have x minus 1. So again, 4th degree, I should have 4 answers. So by the time I get to the bottom, I have my 4 factors. To find the zeros, I set them equal to 0 and solve for x, or I look at it and figure out what's going to make a 0. So +1, +2, -1, -2. Those are the 4 numbers that are going to be my zeros. And that's it for synthetic division and synthetic substitution. After that section was the perfect square and square roots. That's what we started with at the beginning of class when you Skyped in. Was just seeing how well you remembered your squares 1 through 12 and being able to take the square root of numbers. And then that specific notation on the 3rd page of that says radical x equals x to the 1/2. So recognizing that raising to the 1/2 power is the same as taking the square root of a number. So there's one example on the page that starts 64 to the 1/2 power. That's just 8. It just means take the square root of that number. And we'll get into that exponential notation versus radical notation as we go along. But this is the introduction of it, and you'll see it when we do cubes. But we are not going to do cubes until Monday. So if you finish this video, I have attached the homework is and where we'll start going over Monday. I'll scan that in Friday. This is Thursday afternoon. So you'll have that for the weekend. 10 problems that are circled. And then if you are here Monday, hopefully all is well and you can make it, then you will be right exactly at the same place as everybody else in the class, minus 1 quiz you'll have to make up from lessons 1 through 5. Hope you're doing well. If you're watching this on Friday, have a great weekend. If you're watching this on Sunday, I hope you had a great weekend. And thoughts with you. Hoping you're getting better and we can have you back in school soon. If not, we'll get you back on the video and get you into class if you're up for it.